we are supposed to shed more light on what is a tubule transport system and what are the site of actions for diuretics. So this is more of like you are trying to classify diuretics based on where on the nephron they will act. So this is classification based on site of action. Okay. So the tubule transport system, we said that the nephrons have specialized segments, each with their own transport properties. The proximal tubule will reabsorb 65 to 70% of sodium, chloride, water, glucose, amino acid. So it makes use of what? Sodium potassium ATPase transporter, sodium glucose transporter, sodium hydrogen transporter. You understand? How about loop of Henle? Is mainly water, okay, not solutes. But the thick ascending limb is impermeable to water but absorbs solutes, okay, absorbs sodium, potassium, chloride. All right. Then for the distal convoluted tubule, this one absorbs about 5 to 7% of sodium and chloride via the sodium chloride symporter. It does not absorb water. Okay. Collecting tubule is the final regulation, so it will now check which part of these things does the body still need. Does the body need sodium? Does it need potassium? Does it need hydrogen? You understand? So site of action of different diuretics now. The carbonic anhydrase will work at the proximal convoluted tubule. The osmotic diuretics will act at the proximal tubule and descending limb. The loop diuretics will act at the thick ascending limb. The tarsal diuretics will act at the distal convoluted tubule. The potassium sparing will act at the collecting tubule. Now I'm just listing and passing. Why? Because all of this classification of diuretics will come back and talk about their mechanism of action and also the examples of drugs that fall under each classification. All right. So this is what we have.